Welcome back to Bavarian RC. Today I'm gonna show you how to build the Bavarian RC Noratlas. If you haven't seen the release video, check the link in the description below. The Nord 2501 Noratlas was a military transport aircraft developed in the late 1940s. It saw operation mainly in the French and German Air Force. Designing the Noratlas was pretty much inspired by a control line Noratlas designed by my dad back in the late 1950s. In this video I will run you through the complete build process. If you are familiar with the techniques used on many of the flight test designs, you will have no problems to build this plane. Let's start with the fuselage. Take the part for the lower deck and carefully trace the score cuts with a box knife that has a rounded tip. Be careful not to cut through the paper on the other side. Run along the two lines on one side and then do the same on the other side. Now you need to remove the foam from the cavity. Also on the other side. Take a barbecue skewer and a ruler and slightly score along these lines. You don't have to apply a lot of power, just a little bit. This will allow the foam to be bent towards the lower deck structure. Do the same on all four corners. Now this is an A-fold, so the side part will be glued above the part in the center. Run a bead of glue along the cavity, start at about half a centimeter inside and go all along the cavity, stopping about half a centimeter before the end. Then keep the side part on the table and rotate the rest up. Remove the excess glue with a scrap piece of foam. Check that everything is square and wait about 45 seconds until the glue has cooled down. Then go ahead and do the same on the other side. Now put some glue on this portion. Flip it around and push it to the table so that the angled element rests flat on the table. It will easily fold at the line where we made the score line before. Do the same on the other three portions. Once you flip the part onto the table, move it a little bit so it won't stick to the table in case you have some glue seeping out. The lower deck is now done and it should look like this. Before we go ahead, let's put some tape on in order to reinforce the lower deck. You can either cover the whole lower deck or just the front and rear part if you want to save some weight. Start at the front edge of the cutout and move your way to the front. The first layer should go around the edge to the side of the lower deck. You'll need to make a small cut here in order to work the tape around the corner. Put the next piece of tape in the middle, overlapping about 1 centimeter. And the last piece of tape on the other side, again with an overlap. Now trim off all the excess. Do the same on the rear end of the lower deck. Start with the tape where the rear tab is located. Again, put the tape in the middle with an overlap. And finally, the last strip of tape on the other side. Cut away all the excess. The next part is the main fuselage. Trace all the score cuts, being careful not to cut the paper on the other side. Also cut the little tab on the bottom plate without cutting the paper on the backside. Remove the foam from the cavities. Take a barbecue skewer to remove the foam tabs on the bottom plate. Do a test fit with the lower deck. The tabs at the bottom have different sizes, so you can't fit the lower deck in the wrong way. Mark the position of the main fuselage on the lower deck. Then run a bead of hot glue along the edges between the marks. and push the lower deck firmly onto the bottom plate. Remove the excess glue and hold everything for about 45 seconds flat on the table. Now it's time to install the reinforcement plates for the barbecue skewers that will hold the wing. My plates are 3D printed, but you can also cut them from plastic gift cards or thin plywood. The positions of the 4 holes are marked with a small cross in the plan. Take a barbecue skewer and punch it through the side plates. Keep the barbecue skewer inserted in the hole and then put a bit of glue on the plate. Thread the plate onto the barbecue skewer and push it against the sidewall. Rotate the barbecue skewer to prevent any hot glue from sticking to it. Repeat the process for the other 3 holes. Now put a bead of glue in the cavity and on the sidewall of the lower deck. Rotate the sidewall up and push it against the lower deck and also down on the table. Check that everything is square. Wait about 60 seconds for the hot glue to cool down. Apply a thin line of hot glue to the joint. Now repeat the process for the other side wall. Don't put any glue on the top plate. Check that the top plate is fitting nicely, making it a kind of square box. Again, wait about a minute. Now add a bead of glue to both sides of the top plate and fold it into position. Flip the fuselage around and press it to the table. Check that everything is still square. Now you can pop out this tab. The next part is the rear fuselage joiner. Trace the score cuts without cutting the paper on the back. Then remove the foam from the cavities. On this piece we have an A-fold, so the side plates will go above the center plate. Apply some glue to the cavity. Put the side plate on the table and rotate the center plate 90 degrees. Check that it is square and hold it for about half a minute. Then do the same on the other side. Do the exact same process for the forward fuselage joiner. You might wonder why the center plate is wider than the rest. The reason is that I put a run cam on top of the fuselage and it is screwed to a counterplate which is glued onto this part. Test fit the fuselage joiner and adjust if necessary. Mark a line 10 mm from the front edge all around the joiner. This will help to position it inside the fuselage. Apply a good bead of glue to the inside of the fuselage where the joiner will be seated. Also add some glue to the center plate of the joiner. Then slide the joiner into the fuselage and align it with the mark that you made before. Press all sides outside against the fuselage. Do the exact same thing on the rear fuselage joiner. Again, mark a line 10 mm from the rear edge of the joiner. Test fit it, and if everything is okay, glue it into the fuselage. Now let's add some tape to the underside of the fuselage. This will protect it during landing. Align the strip with the outer edge of the fuselage. Do the same on the other side. The tape will overlap in the middle. Trim the tape at the front and rear end. The next part is the front nose cover. Peel off the paper, starting at the score line all up to the tip. Do that on both side panels. trace the 4 score cuts. Again, be careful not to cut the paper on the other side. And remove the foam from the cavity. Now you have to mold the portion of the side panels where you just removed the paper. You don't need to mold it too much, just a little bit to give it a light curvature. Now that's what we want. Before you start gluing the part, get a piece of paper with a grid on it. This is a B-fold, so the side panel will go beside the center panel. Add some glue. Push it down on the rear end. Remove the excess glue. And then align it with the grid on the paper. It should rest nice and flat on the table. Let it cool down for about a minute. Then repeat the process on the other side. Again, check that the plates are aligned with the grid and the nose cover rests nice and flat on the table. Once that's cooled down, we can work on the nose skin. Be careful to use the correct one, as there is also skin for the rear cover. Trace all the score cuts and remove the foam. Make some relief cuts to ease the removal of the foam along the hourglass shape. Break the foam along the score line. Now peel off the paper. Do a test fit to see if everything lines up on the lower part. Mold only the nose part of the skin to fit to the curvature of the side plates. Put the glue only on the paper. We don't want any glue on the foam for now. Then align the nose cover with the skin so that the paper part with the glue is sticking to the center plate. You see that we have a kind of hinge now. So in the next step, put glue on the foam where the hinge is. And on the outer perimeter, but only go up to the score line, which is building another hinge. Put it flat on the table and push the side walls towards the inside, while rotating the nose cover a bit forth and back. Let this cool down for a good minute. Now you can do the same thing on the next hinge line. On the side cavities only go as far as the nose tip for the moment. This might look a little bit tricky and you might have a different way of doing it, but this is how it worked best for me. Let this cool down for a good minute. In the last step, put glue on the perimeter all up to the end. Push the skin into place and hold the side walls against the skin. Flip it over and press it to the table while rotating forth and back. The rear end of the skin has an overlap that you can now trim off. In this step, we'll apply some tape to the underside of the nose cover, going all the way up to the nose tip. This will make it last a lot longer. Trim off the tape on the outside. If you want to make it even stronger, you can also put some tape on the inside. It's time to test the fit of the nose cover on the fuselage. Now let's continue with the rear cover. Trace the score lines of the lower part of the rear cover skin. Then remove the foam. Remove the paper on the inside. Mold the plate to give it a light curve. Check the fit on the rear cover side plates. Trace this score line on the upper part of the rear cover skin and remove the foam. Then trace the score line along the hourglass shape. Make some relief cuts and remove the foam. Now tear off the paper on the inside. Draw the plate over the edge of the table to round it a bit. This should be enough. Remove the paper on the inside of both side plates. Round them slightly by pulling over the edge of the table. This looks perfect. Do the same on the other side. Put some glue on one side of the lower skin part. Position the side plate so it lines up at the rear end and push it down with small rotating movements. Align it with the grid on the paper. It should rest nice and flat on the table. Let it cool down for about a minute. Let's glue the other side in the same way. Align it with the grid and wait about a minute until the glue has cooled down. Test fit the skin to see if everything lines up perfectly. The next steps are similar to what you did on the nose cover. First, put glue on the paper and attach it to the bottom part of the skin. You should have a nice hinge now. Then put a bead of glue on the hinge and on the perimeter of the skin, but only go up to the tip of the cover. Roll the cover on the table and push the side plates to the inside. Now we can put glue on the rest of the perimeter. Roll the cover onto the skin while putting some pressure on the sidewalls. The rear end of the skin should have an overlap that you can now trim off. On this part you should only reinforce the section where the barbecue skewer will go through. Do the same on the other side. The position of the barbecue skewer is marked on the plan with a little cross. Push the barbecue skewer through one side and also on the other side. Install the rear cover on the fuselage and check that it lines up nicely. Then punch the barbecue skewer through one side with a rotating motion. And also from the other side. You should now have a hole on both sides of the lower deck. We need 2 reinforcement plates for the barbecue skewer. Insert the barbecue skewer on one side and then put a bit of hot glue on the plate. Thread the plate onto the barbecue skewer and push it against the lower deck sidewall. Rotate the barbecue skewer to prevent any hot glue from sticking to it. Repeat the process for the other side. To ease the inserting of the barbecue skewer, we will install a guide made from a soda straw. Cut the straw to the correct length so it fits exactly in between the 2 reinforcement plates. Install the straw together with the barbecue skewer. Then use CA glue to attach the straw. The activator spray will help making a nice and strong joint. That's how it should work. Your fuselage with the nose and the rear cover should look like this now. The ESCs will be installed in the fuselage, and we need to make sure that they get enough air for cooling. Therefore, I have added 3D printed NACA ducts on both sides of the fuselage. If you don't have a 3D printer, you can simply cut the NACA ducts into the fuselage sidewall, like shown on this scrap piece of foam. Cut along the perimeter of the NACA duct, going all around except the short line, where we only need a score cut. Use the barbecue skewer to trace the score cut. And then push it to the inside. For those of you who have a 3D printer, you can download my free STL files. The link is in the video description below. You will need to activate supports in your print settings. I'll put all my settings as well in the description. Remove the supports. Bent nose pliers or needle nose pliers will work best for this step. Mark the position of the NACA ducts on the side panel. Align the plan with the fuselage and then trace the outline of the duct with a pin, making a small hole every few millimeters. Then cut out the shape of the duct. Test fit the NACA duct and make a bevel cut on the rear end of the duct. Put a small bead of glue around the perimeter of the cutout. And insert the 3D printed part. Clean off any excess glue. Do the same steps on the other side. The NACA duct will direct a flow of air to the inside of the fuselage, but only if we have a hole in the rear cover where the air can escape. If you don't have a 3D printer, just make the rectangular cutout in the rear cover. If you have a 3D printer, you will need to activate supports in your settings. The link to the STL file is in the description below. Remove the supports. Now you need to mark the position of the cutout on the rear cover. To do so, print out the template and position the rear cover correctly over the printout. Make sure that the hole for the barbecue skewer is on the correct side. It is marked with a small cross. Use a rectangle to transfer the upper and lower outline to the rear cover skin. Then align the air outlet with the lines, center it, and trace the outline with a pen. Cut out the rectangle. Test fit the outlet and adjust the cutout if needed. Put a small bead of glue around the perimeter of the cutout. And insert the air outlet. In the next step, we will build the tail boom. When cutting out the tail boom, you will notice that the tail boom top part is a separate piece from the tail boom. It will come loose once you cut out the tail boom. Also take out this piece. Now trace the score lines without cutting the paper on the back. Remove the foam from the cavities. To ease the folding, you can shorten the tabs by about 1 mm. Remove the foam here. And there. Also, pinching the tabs a little bit will make the fold easier. Do a test fit of the B-fold, so the side plates will go beside the center plate. It should look like this now. Trace the score lines without cutting the paper on the back. Remove the foam from the cavities. Remove the little piece of paper at the rear end. Let's glue the first B-fold. Put the center plate on the table and rotate the side plate. Remove the excess glue and check that it is square. Let it cool for about 45 seconds. Then run a bead of glue on the other side of the B-fold. Rotate the side plate up. Remove the excess glue. Check that everything is square. And also check the fit of the center plate. Hold everything for about 45 seconds. Before going on, I recommend cutting a small piece of foam board with the same width as the inside of the tail boom. Watch this complete step first before you start gluing. Now put glue to both sides of the center plate. And fold it down. Check that it is aligned with the side plates. Now insert the little foam board piece and press the side walls against it. This helps making the tail boom perfectly square. In the front of the tail boom we have a C-fold. So you will fold it 180 degrees and the paper in the cavity will cover the plates. Then apply glue on the paper and on the plate. Fold it over and run a scrap piece of foam along the front edge to get a nice surface. Put the tail boom on the table and hold it for half a minute. Now you need the tail boom upper part. Put a bead of glue on both sides, but stop at the point where you removed the paper. Align the front of the plate with the tail boom structure and then slide it between the sidewalls. Flip the tail boom around and press it to the table, while pushing the sidewalls to the inside. Again, a small piece of foam board with the correct size helps making the tail boom square. Let it cool for about a minute. Then put glue on the rear end and bend it around the curve. Unfortunately, my camera was not running when I did this step, but it is the same step as for the tail boom bottom, which is shown here. Trim the overlapping part. Take the two frames and trace the score cuts without cutting through the paper on the back. Then remove the foam. Test fit the frame in the front. And in the back. Apply glue on the perimeter of the rear frame. And on the front side of the center plate. Insert the frame. Do the same steps for the front frame. Now take two of the tailboom doublers. Test fit the doubler. The front edge of the doubler should align with the rear end of the rear tab. Apply some glue on the doubler. And also a line here behind the tab. Then insert the doubler and ensure that it has an even spacing with the underside of the tailboom. Keep the pressure right in the middle. The doubler will bend a bit and fit nicely to the shape of the tailboom. Do the same on the other side. That's how it should look like. Now take the rear tailboom bottom plate. Trace the score lines without cutting through the paper on the back. Remove the foam. This is exactly the same process as you did for the tailboom upper part. Remove the paper. And take out the tab. Do a test fit aligning the forward edge of the plate with the corner of the side plates. Before gluing the part, you need to trim the foam at the rear end. Don't cut the paper yet. Then fold it over and make a bevel cut. Check if it fits nicely within the rear end. It should be completely flush with the shape of the side panels. Put glue on the outside all the way up to the middle of the tab. Align the plate at the front with the corner of the side plate and slide it between the side walls. Flip the tail boom around and push it against the table. Move it a little bit to avoid sticking to the table. Now let's take care of the rear end. Add glue on the side and a drop here. And use a scrap piece of foam to push it in place. Then flip it around and hold it against the table while rotating forth and back. Trim off the paper. In the next steps, we will build the two power pots. They are not compatible with the Flight-Test Mini power pots, but the design is very similar. Trace the score lines without cutting the paper on the other side. Remove the foam from the cavities. On the power pots we have an A-fold, so the side plates will go above the center plate. Apply a bead of glue. It is better to put the glue more towards the side plate and not like I am doing here towards the center plate. Put the side plate on the table and rotate the center plate up. Remove the excess glue and check that it is square. Then do the same on the other side. Apply a bead of glue, lay the side plate on the table and rotate the rest 90 degrees up. Remove the excess glue and again check that everything is square. In the next step we'll need the firewall. My one is 3D printed, and you can download the STL file with the link in the description below. But you can also cut it from 2.5 mm plywood using the template on the plan. You might need to adjust the mounting holes depending on the motor that you use. Check the fit on the power pot. It should be flush on all sides. Apply a bead of glue on the front side of the power pot. And adjust the firewall. Press it against the table and let the glue cool down for half a minute. Now let's reinforce the power pot with packing tape. If you want, you can also use fiber reinforced packing tape. Align the tape with the upper edge of the power pot. and run it across the firewall to the other side of the PowerPod. Trim the rear end of the tape on both sides. Cut the tape at the corner and work the tape around the edge. First the front part, then on the side, just like wrapping a Christmas gift. Finally, trim the tape at the step of the PowerPod. Remove the tape that is covering the holes. And remove it also on the upper corner where the motor wires will be routed. Do the same process for the second PowerPod. Use a barbecue skewer to punch through the holes for the barbecue skewers connecting the PowerPod to the tail boom. They are marked in the plan with a small cross. There are 2 holes on one side and 2 on the other side. Now insert the PowerPod and align it with the tail boom. It should be seated nicely against the box-type structure inside the tail boom. The underside of the PowerPod should be parallel to the lower edge of the tail boom. Then use a barbecue skewer to transfer the 4 holes to the PowerPod. Make sure that the PowerPod is always held in the correct position. Remove the PowerPod. Time for some more reinforcement plates. We'll need 6 small ones and 2 bigger ones per tail boom. My plates are 3D printed, but you can also cut them from plastic gift cards or thin plywood. The thickness is depending on the fit of your PowerPod inside the tail boom. The PowerPod should have a snug fit between the plates. Insert a barbecue skewer in the front hole and test fit one of the bigger plates. Apply some hot glue. Thread the plate onto the barbecue skewer. And press it against the side wall. Rotate the barbecue skewer to prevent any hot glue from sticking to it. Do the same on the other side. Go ahead and apply the same procedure for the rear holes, using the smaller reinforcement plates. Test fit the plates before adding glue. It should look like this now. Now you need 4 of the smaller reinforcement plates. They will be attached to the inside of the power pot. Insert the barbecue skewer, apply some glue, and thread the plate onto the barbecue skewer. Push the plate against the sidewall of the power pot and let it cool down, while rotating the barbecue skewer a bit. Do the same on the other 3 plates. Insert the power pot and then attach it with 2 barbecue skewers. Check the fit, especially that the underside of the power pot and the lower edge of the tail boom are still parallel. Cut the barbecue skewers, letting them overlap about 4 to 5 mm over the sidewall. Do the exact same steps for the second power pot and tail boom. To start with the wing, let's trace all the score lines with a knife that has a dull tip. Go all along the lines and be careful not to cut through the paper on the back. Do the same on the other half of the wing. Cut out this piece. This is where the servo will be located. Trace these tabs without cutting the paper on the back. Use a barbecue skewer to remove the foam from the cavities. Again, do the same thing on the other wing. Then trace the score cuts on the inner tabs. Be careful not to cut through the paper on the other side. Use the barbecue skewer to remove the foam. Do the same on the other side. Use a barbecue skewer to widen the 3 score lines on the upper part of the airfoil. Don't rush things. Go through in multiple passes. You can see that I start with the pointed end and then use the blunt side of the barbecue skewer. Perform this step on the inner section of the wing. And repeat the process on the outer section of the wing. Also do the same on the 2 additional score lines at the wingtip. Check that your wing looks like that. Repeat the steps on the other wing. Now break the foam along the score line at the leading edge. Fold the plate over like this. In the next step we will make a double bevel cut here and there. Align the wing with the edge of the table. Take a razor blade or box cutter with a very sharp blade and run it along the edge in a 45-degree angle. Be careful not to cut the paper. Take your time for this step and always know where your fingers are and where the knife is. Flip the wing around and repeat the process. Again cutting a 45-degree bevel without cutting the paper. Remove the foam on this section. Break the foam along the score line at the leading edge of the outer wing section. Fold the plate over and again make a double bevel cut like for the inner section. I usually don't cut too close to the paper hinge at the leading edge, but rather use a sanding block to fine-tune the bevel. Once you have completed this step, your wing should look like that. Do the exact same process on the other wing. Now you can remove the 4 tabs on each side. And you can also pop out the circle. Test fit 2 barbecue skewers in the channels. Now this is important. Make sure that they fit without any pressure. Otherwise they will try to bend open your airfoil at the wingtip, resulting in a too flat profile. I made this mistake on my Noratlas. Going into a tight turn with a steep bank angle, the plane experienced a stall and crashed. Analyzing the root cause, I found out that on the prototypes the airfoil in the area of the wingtip was much more curved, which explains that I never had this issue before. Apply a bead of glue in the cavity and insert the barbecue skewer. Remove excess glue with a scrap piece of foam and hold the wing flat on the table for 1.5 minutes. Then do the same for the second barbecue skewer. Repeat the process for the other wing. Check that both wings look like this now. Flip the wings over and align them in the middle. Secure them with short strips of tape. Then run packing tape along the whole length of the seam. Trim off the tape on the rear and front edge. Open the hole where the wiring will be routed through. Now lift the wing in the middle and run a bead of glue along the seam. Put the wing flat on the table and remove the excess glue. Let it cool down for at least a minute. Now put tape on the inside of the joint. Cut the tape at the score lines and the bevel cut, and use a barbecue skewer to push it inside the cavity. In the next step, we will install the 2 spars. Do a test fit and check that the tabs go inside the cavities. Start inserting them in the middle and then bend the spar slightly on the outer part to match the tab. Do the same on the other spar. Carefully remove the spars. Take care not to wrinkle the parts as they are rather skinny. Apply glue to the lower edge of the spar. Then position the spar on the wing, starting on the outer tab and then inserting one tab after the other. Check that the wing is perfectly flat on the table and push the spar down. Remove any excess glue. Let this cool down for a good minute. Then repeat the process for the second spar. Apply a bead of glue. Insert the first tab and then work your way to the other side. Remove excess glue and hold everything flat on the table for 1.5 minutes. Make sure that the glue has fully cooled down before continuing. Now the spar will be reinforced in the middle with 2 popsicle sticks. Test fit the popsicle sticks. They should not be higher than the spar. Apply a good bead of hot glue and install the popsicle stick to the outside of the spar, right at the center of the spar. Do the same for the second popsicle stick and install it to the outside of the other spar. You can be quite generous with glue on the popsicle stick, as the wood will cool down the hot glue rather quickly and you want to be sure to have enough time to properly position the popsicle stick. Take the 4 spar doublers and test fit them on the inside of the spar, at the position where the tapered wing section starts. The upper edge should be flush with the upper edge of the spar. Apply a bead of glue to the side of the doubler and also on the lower edge. And attach it to the inside of the spar. Do the same for the second doubler. Remove the excess glue and push the doubler against the spar. Repeat the process for the 2 doublers on the other side of the wing. In the next step, we will start folding the wing. First, take the middle section of the wing, fold it over, and slowly work it into the correct shape. Don't rush things. The foam will need a bit to adapt to this shape, especially at the leading edge. Check that the folds line up with the outer edge of the 2 spars on both sides. Before starting to apply glue, I usually mark all lines where I need to put glue on. By doing so, you won't miss any glue line in the rush of folding the wing. The glue needs to run along the score lines, along the double bevel, the 2 spars, and the rear end of the lower wing skin. You will need a lot of hot glue for this step. Make sure that your glue gun has enough glue stick and is able to produce a big amount of glue in short time. I usually heat up also my spare glue gun, just in case I might run into trouble. Now run a good bead of glue along the score lines, along the double bevel, the two spars, and the rear end of the lower wing skin. Remove the excess glue on the score lines. Then fold the wing over. And position it correctly with the fold lines matching the outer edges of the two spars. Position the wing at the edge of the table and hold the wing down for about 1.5 minutes to let the glue cool down. The more glue you use for this step, the more time you will have for adjustments, but also more weight. Let's test fit the tapered section of the wing. Fold it over and slowly work it around the spar. Check that you get a nice fit along the edge of the center section. Adjust if necessary. Once you're happy with the fit, go ahead and mark all the lines where we need to put glue on. The 3 score lines, along the double bevel, and the 2 spars. Then fold the wing over and flip the aileron up. Mark the position of the hinge line of the aileron on the overlapping part of the lower wing skin. Mark the position of the glue along the rear edge of the lower wing skin and along the inside of the line on the overlapping part. Don't put glue on the overlap. It will be trimmed off after the wing is fully glued. You know the drill. Run a good bead of glue along the score lines, along the double bevel, the 2 spars, and the rear end of the lower wing skin, and on the inside of the overlap. Remove the excess glue on the score lines, and then fold the wing over. Align it at the seam with the center section, and also ensure that the wingtip is properly curved. This is important, as the wingtips tend to be more flat than the rest of the wing, causing higher stall tendencies. Let this cool down for a good minute. Repeat all the steps on the other side of the wing. Run a thin bead of glue along the seam between the outer and inner wing section and squeeze it with a scrap piece of foam. First on the rear part of the seam and then on the front part. Try to work the glue into the seam. Do the same on the other side. Fold up the aileron and trim the overlapping part of the lower wing skin to be flush with the hinge line. Then repeat the step on the other side of the wing. Now let's take care of the leading edge. Use a ruler and align it with the leading edge of the section where the wing was folded over. And then score cut the foam on the outer section. Be careful not to cut the paper on the back. Remove the foam. The paper will now be folded around the leading edge, giving it a nice and clean look. Apply a bead of hot glue. And then fold the paper around the leading edge using the table. Add more glue to the edge and flatten the paper with a piece of foam where needed. Repeat the same process on the other side. That looks nice. The seam between the center and the outer part of the wing needs to be reinforced with packing tape. Let it overlap about 2 to 3 centimeters at the leading edge and work it around the edge to the underside. At the rear end, trim the excess tape at the rear edge of the wing. Add another tape on the underside, overlapping at the leading edge with the tape from the upper side. Cut the tape at the rear end of the lower wing skin. Remove the tape from the cavities. Now do the same process on the other side of the wing. Flip the aileron over and align the wing with the edge of the table. Take a razor blade or box cutter with a very sharp blade and run it along the edge in a 45-degree angle. Be careful not to cut the paper at the hinge. Take your time for this step and always know where the knife is and where your fingers are to avoid any injury. If you are afraid of cutting the paper at the hinge, you can always come back with a sanding block to adjust the bevel. Repeat the same step for the other aileron. Run a light bead of glue along the hinge and smear it with a scrap piece of foam. This will make the hinge very strong and durable. Let it cool down for at least half a minute. Turn over to the other aileron and repeat the step. Now grab your servos for the ailerons and 2 servo extensions with 400 mm length. I am using the Emax ES9051 servos, but you can also use any other 5-gram servo. Connect the servos to the extension wires. Check that the colors of the wires are matching. Before installing the servos, you'll need to center them. You can either use a servo centering tool or, like I'm doing here, hook them up to your receiver. Switch on your transmitter and connect the battery to your receiver. The servos are now centered and you can install the servo arms. Insert the servo wire behind the spar and push it towards the center of the wing. Use a pair of pliers to pull the wire out at the center hole. Test fit the servo. The control arm should be located on the side which is further away from the aileron. Adjust the cutout to fit to the servo. And again test fit the servo. Use a 1 mm steel wire for the push rods. Make a Z-bend on one side. Then use a barbecue skewer and run it along the little score line. Test fit the control horn on the aileron. The hole for the pushrod should align with the hinge line of the aileron. I'm using a 3D printed Flite Test mini control horn. You can also make it from 2.5 mm plywood. Center the aileron. I'm using 2 popsicle sticks and small clamps to hold the aileron in a neutral position. Connect the pushrod to the servo arm using the middle hole. And mark the position of the hole on the pushrod. Make a C-bend on this end of the pushrod. After a test fit, you're ready for gluing the servo. Connect the pushrod to the control horn and to the middle hole of the servo arm. Again, make a test fit, and if everything is okay, put a bead of glue in the cavity and insert the control horn. Let it cool down for a good minute. Repeat the process for the other side. Again, take care to have the servo arm on the side that is further away from the aileron. If needed, apply some more glue around the edge of the servo. And remove the excess glue with a scrap piece of foam. Make the pushrod connected to the control horn and the middle hole of the servo arm. Apply a bead of glue, insert the control horn and let it cool for about a minute. In the next steps, we will build the horizontal stabilizer. Trace the score cut that is right next to the tabs, without cutting through the paper on the back. Make a second cut with a distance of about 2 mm. Again, don't cut through the paper on the back. Use a barbecue skewer to remove the foam. Run the barbecue skewer along the line and make sure that the cavity is free. It is important that the barbecue skewer fits in the cavity without pressure. Otherwise, you will have a risk of warping the horizontal stabilizer when inserting the barbecue skewer. Test fit the barbecue skewer and cut it to the same length as the horizontal stabilizer. Apply a bead of glue along the cavity and insert the barbecue skewer. Remove any excess glue. Press the horizontal stabilizer flat on the table and let it cool for a good minute. Cut along the score line of the elevator without cutting the paper on the back. Fold the elevator to break the foam. Align the horizontal stabilizer with the edge of the table and carefully cut a 45-degree single bevel on the elevator. Be careful not to cut the paper at the hinge. Take your time on this step and watch out for the knife. If needed, take a sanding block and adjust the bevel. Apply a thin bead of glue along the hinge and smear it with a scrap piece of foam. Let it cool for half a minute. Take the right-hand tail boom and make the cutout for the servo. Open the tab for the horizontal stabilizer. Also remove the tab for the horizontal stabilizer on the left-hand tail boom. Test fit the horizontal stabilizer between the two tail booms. In the next steps, we will glue together the wing, both tail booms, and the horizontal stabilizer. Use a pen and run it along the underside of the trailing edge of the wing where the tail boom will be located, to make a light bevel. Do the same on the other side. Test fit the tail boom. The tabs on the tail boom should fit into the cavities on the wing, and the tail boom should seat flat on the wing. If needed, you can shorten the tabs on the tail boom or rework the bevel on the trailing edge of the wing to improve the fit. Also test fit the other tail boom. If everything is fine, remove the tail booms and grab your hot glue gun. Apply a bead of glue starting at the rear end. Go around the cavities, over to the other side, and back. Add some glue in the middle and align where you made the bevel at the trailing edge. Attach the tail boom, make sure that the tabs fit into the cavities and the tail boom rests flat against the underside of the wing. Flip it over and press it against the table. Let the glue cool down for a good minute. Repeat the same process on the other side. Apply the hot glue, insert the tail boom, flip it over and press it flat on the table. Again, give it a good minute to cool down. Take 2 popsicle sticks and 2 small clamps to fix the elevator in a neutral position. Test fit the horizontal stabilizer. You'll have to carefully bend the tail booms to the outside in order to install the horizontal stabilizer. Check that the horizontal stabilizer is perfectly parallel to the upper side of the tail boom. I made myself a template out of foam board that has 2 parallel edges. The height is equal to the distance between the horizontal stabilizer and the upper side of the tail boom. The template will help adjusting the horizontal stabilizer when gluing it to the tail boom. Remove the horizontal stabilizer and apply a bead of glue from the leading edge over the tab up to the hinge line. Only apply glue on one side of the horizontal stabilizer. Be careful not to put any glue on the elevator. First insert the horizontal stabilizer on the side without glue, and then on the side where you put the glue on. Use the template to make sure that the horizontal stabilizer is perfectly parallel to the upper side of the tail boom. Let it cool for about a minute. Run a thin line of glue along the joint and remove the excess glue with a scrap piece of foam. Move it from the rear to the front to avoid any glue getting on the elevator. Do the same on the underside. Pull out the horizontal stabilizer on the other side. Apply a bead of glue. And insert it again. Remove the excess glue. And again use the template to make sure that the horizontal stabilizer is parallel to the upper side of the tail boom. Wait about a minute until the glue has cooled down before you go on. Remove the popsicle sticks and check that the elevator has free movement. Take the rear tail boom wing cover. Remove the foam from the cavities. Do the same for the forward wing cover. This is a B-fold, so the side panel will go beside the center panel. Put a bead of glue in the cavity. Apply it more on the inner part of the cavity. Put the center part on the table and rotate the side panel up. Check that it is square. And remove any excess glue. Do the same on the other side. Mark a line connecting the two intersection points between the side plate and the center plate. Make a score cut. And remove the paper. Then make a bevel cut. The cut doesn't have to be perfect. Use a sanding block until you have a sharp edge at the rear end and the surface is flush with the side panels. The process for the forward tailboom wing covers is in principle the same. It's just a bit trickier due to the small size of the part. Again, this is a B-fold, where the side plate goes beside the center plate. Put the center plate on the table and rotate the side plate 90 degrees up. It is difficult to use a triangle to check if it is square. Just eyeball it. Do the same on the other side. Again, connect the two intersection points. Make a score cut. And remove the paper. Make a bevel cut. And use a sanding block to build a nice and sharp edge. Repeat the process for the second front and rear wing cover. Now test fit the covers on the wing, aligning them with the tail boom. The rear cover is oversized by default, so that you can trim it to the correct size. Put it beside the tail boom and move it back until the upper sides are flush. Then mark the position of the tail boom corner on the cover. Make a line around the cover, staying parallel to the rear edge. Trim the cover along the line. Again, test fit the cover. That looks great. You might also need to adjust the forward cover. Once it fits, apply a bead of glue all around the perimeter. Be careful not to touch the hot glue with your fingers. Insert the cover and align it with the tail boom. Use a steel ruler to press the cover against the wing in order to have a flush seat on the upper side. Then apply a bead of glue around the perimeter of the rear cover. And align it with the tail boom. Remove any excess glue and check the fit with a ruler. Repeat the whole process on the other side. Now it's time to install the vertical stabilizers. First, make sure that the wing and tail boom assembly is flat and horizontal on the table. Pinch the tabs and do a test fit. If everything is fine, apply a bead of glue along the underside of the vertical stabilizer. You can also put a small bead of glue to the side of the tabs. Insert the vertical stabilizer remove the excess glue and check that the vertical stabilizer is perfectly perpendicular. Let it cool for about a minute. Do the same on the other side. Flip the whole assembly over and grab the lower part of the vertical stabilizer. Pinch the tab. Do a test fit. Take care to have the correct orientation of the stabilizer. If you try installing it in the wrong way, the curvature will not match the tail boom. Apply a bead of glue on the underside and also a small bead on the side of the tab. Install the plate. Remove the excess glue. And align the plate to be perpendicular. You can just eyeball it. Let it cool down for a good minute. Repeat the process for the other side. To make the lower stabilizers more durable, run a bead of glue along the outer perimeter and smear it with a scrap piece of foam. Do the same on the other side. Now grab your servo for the elevator and a 400 mm servo extension wire and connect them. Make sure that your servo was centered before, like you did for the aileron servos. Insert the wires in the cutout of the servo and route them forward through the tail boom. Test fit the servo. The control arm should be located on the side which is further away from the elevator. Take a 1 mm steel wire for the pushrod. Make a C-bend on one side. Then use a barbecue skewer and run it along the little score line on the elevator. Test fit the control horn. The hole for the pushrod should be on the same level as the hinge. Center the elevator with 2 popsicle sticks and small clamps to hold the elevator in a neutral position. Connect the pushrod to the servo arm using the middle hole. And mark the position of the hole on the pushrod. Make a C-bend on this end of the pushrod. After a test fit, you are ready for gluing the servo. Put a bead of glue on both sides and insert the servo. Connect the pushrod to the control horn and to the middle hole of the servo arm. Again, make a test fit and if everything is okay, put a bead of glue in the cavity and insert the control horn. Let it cool down for a good minute. Now push the wire of the elevator servo from the tail boom opening to the opening in the center of the wing. In the next steps, we will install the motors. The Flite Test APAC motors should be perfectly fine for the Noratlas. For each motor installation, you will need the power pod, 4 screws, the motor, and 3 wire extensions. Route all 3 wires from the hole in the tail boom towards the opening in the center of the wing. Do the same on the other side. I'm using two different colors for the motor wires to easily identify which wire harness belongs to which motor. That's how it should look like. Attach the motor with the 4 screws. Repeat this step for the other motor. To secure the screws from getting loose, I recommend applying a bit of hot glue, starting on the firewall and going across the screw head. Secure all 4 screws in the same way. Now it's time to install the 2 power pots with barbecue skewers inside the tail boom. Hook up the motor wires. You will need to test if the motor is spinning in the correct direction. On my twin motor planes, I always install the motors in a way that the prop is spinning on the upper side of the wing towards the wingtip. If you need to reverse a motor, simply swap 2 of the 3 wires. I made this test before and marked the wires accordingly with 1, 2 or 3 stripes. Position the power pot inside the tail boom and insert the barbecue skewers. Repeat the same process on the other side. Take the tail boom bottom and trace the score lines with a knife without cutting the paper on the back. Do the same for the second cover. Then remove the foam on both plates. Test fit the plates on the tail booms. Check that they are not interfering with the power pots. If necessary, adjust the plates by trimming off a bit of the length. Apply a bead of glue around the perimeter. Insert the plate and run a scrap piece of foam along the joint. Remove any excess glue. Do the same on the other side. To protect the trailing edge of the wing in the area where the rubber bands will be located, I designed a 3D printed wing protector. In case you don't have a 3D printer, you can double up the foam board with a small piece of wood from a popsicle stick. For the 3D printed parts, you will find the link to the STL file in the description below. Activate Brim in your print settings. Test fit the parts on the trailing edge of the wing. Position them like shown here. They should overlap about 5 mm to the inside of the fuselage edge. Mark the position and remove the wing from the fuselage. Apply a bead of glue to the protector and then attach it to the trailing edge of the wing. Align it with the mark that you made before. Repeat the step for the other side. This completes the build of the Nord 2501 NORATLAS. If you want to paint your NORATLAS, now is the best time before installing the rest of the electronics. The paint scheme and the decals for my version of the NORATLAS in the colors of the German Air Force are included in the free plans. The link is available in the description below. Now let's install the ESCs and the receiver. First, connect the two ESCs with a Y cable. The Y cable is splitting the positive pin of the battery connector and connecting it with the positive pin of the two parallel plugs. The same for the negative pin. Double check the correct connection when soldering this cable. Otherwise, you could short circuit the battery, which would be quite dangerous. Then connect the motor wires to the controller. Make sure that you connect the wires in the same way as you did when testing the direction of spinning. I use a marking with 1, 2 or 3 stripes to ensure connecting the correct wires. In the next step, we'll hook up all the connectors to the receiver. I always mark the wires with small labels with the channel number and the function of the connected servo or controller. Insert the ESCs and the receiver through the hole on the top of the fuselage and attach them with Velcro tape on the lower deck. Now you can adjust the throw and expo settings of all control surfaces. The elevator should have 15 degrees up and down. The ailerons should also have 15 degrees up and down. Set the expo of the ailerons to 50%. For the elevator I also use 50% expo. Finally, find the position for the battery to have the CG at 27 mm from the leading edge. Your NORATLAS is now ready for its maiden flight. You can easily launch the NORATLAS with full throttle, as the props are counter-rotating, which is eliminating the torque. Get to a safe height and trim the plane. Also check the slow flying characteristics. You will notice that the NORATLAS is not a trainer. Due to the slim wings, it doesn't like flying too slow. If you want to see more of my NORATLAS in action, check the link to the release video in the description below. I hope you enjoyed building my little Nord 2501 NORATLAS. In case of questions, just add a comment below and I will try to answer and help as much as I can. It would also be great to see your NORATLAS in action, so go ahead and add a comment with a link to your flight videos. I wish you safe and happy flying and see you soon on this channel. Thanks for watching Bavarian RC.